In this video, we're going to look at measuring human impact on the environment. And we'll recall the ideas of Thomas Malthus, an economist who worried about the decline of living standards in 19th century England. He assumed that population growth would outstrip resource growth. Now, one thing Malthus didn't include in his estimation was the impact of technology. The fact that technology would improve to allow food production to increase along with population growth. Now, there is a more contemporary approach to trying to measure human impact. And in economics, there's something called the IPAT equation to try and do this. IPAT refers to impact, the I, P for population, the actual number of people we're talking about. Affluence refers to how much those people want to consume. And then the technology refers to the impact for each unit of consumption. So if we want to assess the impact on the environment, that could be emissions, it could be habitat destruction, we need to weigh these different factors. The number of people, the population, how much each person is consuming, and then what is the impact, for example, the emissions that go along with each unit of consumption. Now, we can kind of isolate within this equation two problem areas. Population growth would be a big one. Increasing consumption demands would also be a big one. So if those two things could be reduced, then maybe that's a way of reducing impact. Keeping population growth under control, which was a very Malthusian approach, or just lowering consumption. Another option is technology. Improving technology could decrease the impact per unit of consumption. And so that's trying to make things more sustainable, reducing packaging, reducing the impact for every unit consumed. Now, what happens within this equation when individual factors change? There is definitely a relationship to them, but there's a lot of uncertainty within this model as well. For example, what happens when the consumption per person changes, or technology? That's not really predictable. Population increase could increase consumption, or it might not if tastes change. Same for affluence or technology. There's really no predicting how things might react. And this is an old observation, goes back to William Jevons, an economist who posited that it was a misleading idea to think that a technology that made fuel more efficient, for example, would diminish consumption. And what he's trying to say here is that just because something gets more efficient doesn't mean it will reduce impact. In fact, the opposite might be true. Think of fuel-efficient automobiles. As cars got more efficient, people did not drive less, they drove more, because as automobiles get more fuel efficient, they use less fuel. That effectively lowers the cost of driving. If you lower the cost of something, you're going to do it more. And so this idea is called the Jevons paradox. Something gets more efficient doesn't mean impact will get lower. Impact's probably going to increase because people will do that thing more. Now there's some examples that we can look at. One natural experiment happened by just analyzing the Chinese economy over the past 50 years. There's been incredible growth in China, and it provided a good opportunity to measure the differential impact of different factors. For example, this particular paper chunked the growth into different time periods, looked at the impact, the population growth, the affluence, the technology across each time period. And what's interesting to note is that the population growth rate actually declined. What did that do for consumption? Well, the affluence increased. The demand for consumption increased as well. So it's not always a linear relationship. Impact within that really increased. So even though population was going down, the impact on the environment was going up, in this case measured by CO2 emissions. Why? Well, because of that affluence. Individual people were consuming more resources. And this holds true across jurisdictions as well. It's also useful to think of the role of technology too. How can technology reduce that impact per unit of consumption? Now, just to recap, this is a fundamental challenge. Increasing population, increasing demand for more resources, yet declining resources. And the question mark, of course, being impact. What is the role of population growth? What is the role of affluence? What is the role of technology? There's a lot of uncertainty in this model when we're trying to understand the impact of human activity.